So diffusion tensor imaging is an MRI technique that examines the diffusion of molecules. It sort of tracks how molecules are moving, particularly water in biological tissues. And, where molecules are, water is able to move, that can tell you something about the structure, of the compartments, the structures that it happens to be, traveling within. Particularly the white matter tracks, like these long axonal projections. So DTI is really good, it turns out, at determining, white matter connectivity. And there's a measure, it's got a fancy name, it's called fractional anisotropy, or FA. And it basically is a measure of how diffuse or directed is that diffusion of water being detected by DTI. Is it equal in all directions? Can water go in every possible direction? Well, then the fractional anisotropy is 0. However, if it's really kind of constrained, along one axis, like it's going from here, along one sort of axis, and it can't really go, out in all different directions, if it has a fractional anisotropy that's approaching 1, where it's sort of limited in a particular axis, that suggests that what you're measuring here is water traveling in an axon, so in sort of white matter. So DTI has been utilized a lot now to examine white matter connectivity and how that changes, for example, with adolescent development. So it's a very useful kind of structural technique that tells you a lot about white matter tracks.